Okay, so I hope everyone understood yesterday's lecture. So I guess I got overexcited. In Urdu, it's okay. Let me mute him. So Warren, your mic is on, according to one of the students. Okay, yesterday you could say that I got overexcited, or as they say in Urdu, jazbati ho gaya, and I basically made a little mistake, you could say, or I forgot to mention one thing. Okay, so first of all, I did not share the diagram I promised yesterday. So let's start from this part. So one of the students yesterday asked that how in the world is this mg sine theta? Okay, now I want to know how many of you are confused about it? How many of you are not clear about this concept? And did you study this with Fazl yet? Okay, you are confused. And did you do this in AS yet? Or, I mean, in the school or at their academy? Okay, that's great. So for those who don't know, no problem. Okay, that's amazing. That's great. But still, for those who don't know, I'm gonna try to explain you. Let's see if I can do a good job. So as I said before, I honestly forgot the whole AS, but I still am gonna try to explain this to you. So you know that this is my angle theta, right? So this is my W, and you would be like, okay, so if this is W and this is theta, no problem. So, oh, भेजा था? Okay, I didn't see. No problem. Let me see basically. Can you please, जिस तरह WhatsApp में dot नहीं करते, can you do the dot so I can see the diagram? Anyway, so what I would do, I would make this line here. Again, I might mess up. If I do any kind of mistakes in this part, do tell me. So anyway, my understanding, I tried this on the paper yesterday, and I think it worked pretty fine. So we know that this is a 90-degree angle, right? Right. So if I want to find this angle, can anyone tell me, what is this angle going to be? What is this angle going to be? If this is 90, this is theta, what is this angle? Come on, guys. Let's see your basic knowledge. Basic math, come on. This is O level. Bros, yeah, 90 minus theta. Exactly. So 90 minus theta. Okay, so tell me one thing. Can I say, okay, first of all, do you guys agree that this is a 90-degree angle as well, right? So this is the 90-degree angle as well, right? So if this is 90 minus theta, and this whole angle is 90, so doesn't it mean that this is theta is, okay, I erased it by mistake. So doesn't it mean that this is theta as well? So I don't even need to prove this, but there's one thing. Now, I know that if this is my line, and if I want to find this vector right here, it's gonna be W sine theta or mg sine theta, right? Because I know that this is my hypotenuse and this is my opposite, this is my adjacent. So all of us know that, sine is opposite divided by height. So yeah, and that's how we get mg sine theta. So the one who was confused about this, are you clear about this, or are you still confused about it? Please, I want to know that if you understood it. If you did not understand, please tell me. Okay, great. That's great. Okay, now let me explain the part where I kind of got this wrong a bit. So yesterday I got overexcited and I missed one thing. So this is my pendulum, right? Okay, so this is my pendulum. Let me make it. This is my normal line and this is my pendulum. So let's say this is, at T1, time 1. Now, the thing I didn't mention you yesterday was that, okay, so if I have a curved track, I will use this thing, right? This is my bigger angle and this is my smaller angle. But I kind of forgot about this yesterday. But for pendulums, that's not how you derive mg sine theta. Yes, this part was right. This is mg sine theta. But the way I told you that it's derived, that was a bit inaccurate. Now, let me tell you why. can I say that this is theta 1, right? If this is theta 1, then when my pendulum, okay, so my pendulum is swinging, right? So let's say now it has reached to this point. Now let me make a circle. Now this is my theta 2. So this is my theta 2. Now you can see that I had a bigger angle before, and now I have a smaller angle. So for pendulums, your angle is not going to be this. Yes, it is moving in a curved track, but mind it, your angle is this, and you can see that the angle is changing. Now, but how did I get mg sine theta? Let's look at that. Okay, so if this is my vector, right? This is my arrow. Tell me one thing. Did you study in math when I have two straight lines and I have one line passing like this, and if this is my angle theta 2, can I say that this is theta 2 as well? Am I right, guys? Can I say that this is theta 2? Are you guys clear about this? Okay, so this is theta 2 as well. Okay, so this was just a second. Okay, yeah, this dotted line, it was supposed to be W. Okay, so this was supposed to be W. This was supposed to be W. Okay, so this wasn't my dotted line. This was my W. Now, we're gonna get this line right here, because that's where we're moving. Okay, just a second. Okay, let's complete this arrow. Okay, so now we are gonna get this line right here. Okay, now it's all better. Now this thing right here, this is gonna be W sine theta. Now look at this. This is gonna be my 90-degree angle. This is the 90-degree angle. And you know, if I have an angle, the line in front of it is gonna be W sine theta, right? So do you guys understand it now? So this is my W, and this is my vector, and this is your plane, right? And this is your angle, and this is the line right in front of it. And you know that if I have an angle and I have a line in front of it, that's gonna be my W sine theta. And that's how you derive W sine theta in this. Now, I said that A was G sine theta, right? So G is constant, but my angle, it's changing. That's why my acceleration is also changing. And that's why this pendulum motion is SHM. That's why this is simple harmonic motion. Do you guys understand it? So forget about the yesterday's thing that I said. That was a little mistake I made. I'm not gonna make such mistakes anymore. It's a promise. Okay. Hey, Angie. Hey, Key, did you forget about it? Okay. So we did this in yesterday's lecture. It's not a formula. It's not a formula you're supposed to know. It's something we derived yesterday. So it's just a part of yesterday's thing. Remember this, right? This was it. But it's not important anymore. Okay. I am clearing this in 3 seconds. So for those who haven't noted it down, do note it down. Okay, can I remove this? Can I move on now? Are you guys done with noting down this? Okay, I'm gonna give you 1 second. Okay, so US, you're basically, to understand why I did this, it's a continuation of yesterday's lecture, because yesterday I said that to find the angle, you're supposed to make a line over here, but that's not the case. The angle is from here. You're just gonna have to watch the yesterday's lecture once I upload it. Okay, I'm clearing this. Now, this is officially the start of our second lecture, and this is the stuff that's gonna be a bit confusing. Now, let's make our pendulum. I have a pendulum and I'm swinging it. Okay, so let's say I start from here. This is my time. This is time is equal to 0. So can I say that this distance right here, this is maximum displacement, right? It's my amplitude, but I'm going to say x is max. So this is my maximum amplitude. Now, for this motion right here, for my displacement, we are gonna plot a graph. Now, one thing I have to tell you guys, this thing right here, this is called the mean position. This dotted line is my mean position. And this part where you release your pendulum, this is called the peak position. So remember these terms, peak position. So we are starting at peak position. So just a little note, the graphs we're gonna plot they are for peak position. So we start at peak position, right? So these are for peak position. Now, let's make the graph. Okay, so this is my little graph. Okay, so what do you guys think? If I want to plot a displacement and time graph, this is displacement, this is x, and this is time. What do you think? Is it going to be a line? Is it going to be a curve? What is it going to look like? Come on, I want to hear. Yeah, so Varun says it's curvy. US man says it's line. What about the rest? Okay, so let me tell you, it's going to be a curve, but let's do this together. Now, this is time 0. I'm going to tell you, Ima, don't worry. This is time 0, right? This is time 0. So tell me one thing. At time is equal to 0, is my x the minimum or is it the maximum? It's the maximum, right? I just said it's the maximum. Look at this, Ima. Didn't I say, look, time is equal to 0, x is max. Exactly. So x is going to be max. So I can say that this is my amplitude, right? Now, I know that displacement is slowly decreasing. So I'm going to make this line right here. So my displacement is decreasing because I know that at my mean position, my displacement is 0. So I can, I can confidently say that this line is my mean position. Mean position, right? That's why I'm getting a 0 here, right? Now, I know that displacement is a vector, right? So when it's gonna start to increase again, it's gonna increase in the opposite direction. That's why we're going to the negative side. Otherwise, why would I wanna go there? So let me just switch colors really fast so we don't mix it up with the black here. Now, our displacement is gonna increase. It's actually not down the mean position, it's actually towards the right. So I just said that this is mean position just for better understanding, but in reality, it's moving towards the right, right? Okay, so Key, you're saying displacement decreases. Yeah, in the first part, displacement is decreasing because I know that at mean position, x is 0, right? Because this is my x, this is the length of x. Now, when I start to move again from here towards the right, my displacement starts to increase. This is not decreasing, this is increasing, but in the opposite direction. Now I have to ensure that this is equal to the above. Now, look at this heading I'm gonna make. Now it's gonna be my amplitude, but it's gonna be minus a because it's in the opposite direction, right? Yeah, that's beautifully written, Abdullah. Okay, now I know that it's going to start to move back. It's going to go back, right? So displacement is going to decrease again. So I'm going to go and decrease it. Now, when it passes the mean position, it's going to start to increase again. And it's going to come back to its original point. And this is one oscillation. So this is one oscillation. I mean, yeah, one oscillation. Okay, so Key has a question, but does it stop in mean position? No, it doesn't stop in mean position. It keeps moving. Yeah, it is in continuous motion. No, 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 no. Look, man. Look, understand that displacement is your distance from the mean position, and basically, let me tell you one thing. Okay, so my displacement is the distance from the mean position to the peak position. So when my pendulum, let me make it in red, when my pendulum is moving from this point till that point, this is my displacement. And tell me one thing, when I'm here, have I moved at all? No, it's zero. So X is zero. Now you have to understand one thing. I am slowly increasing my displacement and I have reached my amplitude, right? Now, when it comes back, my displacement decreases. You have to understand that it's not distance, it's displacement. And displacement is the distance between 2 points. Displacement is the distance, the shortest distance between 2 points. Okay, let's imagine that you are at home, okay? So you are Key and you are at home, right? So you're at home and you want to go to school, right? Now, you go to school and this is your maximum displacement. Now, when you come back, and I say that when you moved from this point to that, and when you move back here again, what is your displacement? It's zero, right? Because that's the shortest distance. So it's zero. Now, in this scenario, I want everyone to listen to this part now, because for those who have confusions. Now, let's look at our graph and let's look at this motion. Okay, so I have to use another color. Okay, let's use green. Okay, so my pendulum is at the maximum displacement. It is slowly making its way towards the mean position, and I am saying that my displacement is decreasing. Now, in the graph, we have made our way over here. We are at this point right now. We are at this point. Now, we are gonna move, okay? So now we are moving in the opposite direction. And now I have reached at this point. Okay, so now I am at this point, minus A. Now I'm gonna come back. I'm gonna go back. Now I'm coming back, right? I'm coming back. I am at this point right now. Now I'm at this point. Now, when I go back to my original position, this is this point. This is this point. And as one of the students said, right? As one of the students said, this is the cos graph. This is the cosine graph. For those who do math, it looks exactly the same, and it is my cos graph. Okay, now Key, look. The example I gave you, that was what you just said. So at time 0, displacement is 0. That was only for the example I gave you. But the example we are doing right now, at time 0, my displacement is the maximum. So if you are still struggling to understand what displacement is, just do the way I said. Maximum displacement, 0. Max in the opposite direction, 0. Displacement is maximum, now it's decreasing. Displacement is 0, now it's increasing. Okay, so I hope this makes sense. Does anyone have confusions related to this? Hey guys, is anyone confused about this at all? If you have any kind of confusion, you can ask me, because these are really, crucial basics. Okay, that's great. Okay, just a little question. I want to check your math. What is my gradient at this point? What is m at this point? What is gradient at this point? At time is equal to 0, what is my gradient? Bro. Chill, it's not infinity. Yeah, it's 0. Why 0? Because, man, we make a tangent. So take a line, and yeah, that's my tangent. That's my tangent for time is equal to 0. So my gradient is 0. Okay, note this down, and I'm going to tell you why I said this. I'm going to tell you why I said this. Okay, so I'm going to decrease the size of this so you guys can still note it down. Exactly. Okay, now there's a little thing that I have to say. Let's say I want to know what is the formula for this graph. Sounds weird, right? Because that's new. That's something new. Now, I'm going to write a little formula here. Y label is equal to amplitude multiplied by shape of the curve. This formula right here, this is universal. You can literally use it anywhere, wherever you have a curve and you want to know the formula for the graph. So, what do you guys think? What is going to be the formula for my graph? What is going to be the formula for this graph? Come on, let's see who can get it right. It's a little fun activity, you could say. Okay, what do you guys think? What is going to be the formula for this graph? Okay, so Pakiza has an answer. What about the others? What do you guys think? Come on, 20. There's 20 students. Hey guys, let's see who can get it right. A something. Okay. All right, no problem. So what is my Y label? What is Y label? It's X, right? Y label is X. So Y label is displacement. So I can say that Y label is X. That's displacement. Now my amplitude is A. The amplitude is A. Now, for those who do bio and you were not able to answer this question, no problem. The shape of this curve is cos theta. This is the cosine graph. This is the cos graph. So whenever you have a graph that for which at point, at time is equal to 0, you have the maximum y, that's your cos graph. So now, didn't I tell you guys one thing? Okay, so let's derive this. Okay, so we have not, okay, omega, okay, can you guys tell me what is the formula for omega? The general formula, not the 2 pi one. What is the formula for omega? Hey, guys, yeah, theta divided by time. So theta divided by t. Now, do you guys see this theta right here, right? So can I say that theta is omega t? So I'm gonna simply replace this over here. I'm gonna place this over here. So x is gonna be a cos omega t. And this is the formula for my displacement time graph. So this is the formula for my displacement time graph. Does it make sense? Does anyone have a confusion? Because now we're gonna do the velocity time graph and that's gonna be harder. What? Hey, Ima, did something happen? Okay, great. That's amazing. Okay, great. Can I erase this? Has everyone noted it down? Because I am literally about to click clear and all of this is gonna disintegrate. Yeah, with a simple, okay. Eki, this is not X label. Look, this is displacement. We are not concerned about X label because the formula doesn't need X label. We don't need X label at all. We don't need it at all. Okay? So we are only concerned about this formula. This formula doesn't tell us about X label at all. So don't worry. I mean, we are not concerned about it. So literally, just ignore it. It doesn't matter. Okay. So I'm clearing it. Gone. All right. So now it's going to be a little, you could say a little challenge for you guys. We literally just did the displacement time graph, but what if I ask you the velocity time graph? So this is my velocity and this is time. What do you guys think? What am I going to get now? And also, I want to make something here. Hey, Ima, did you raise your hand? Okay, I'm going to make something here. Okay, no problem. Okay, guys, so let's read Abdullah's answer because he has some explanation, some little explanation there. Okay, so Abdullah has the exact answer. Yeah, it's going to be a curve, guys. It's not going to be a line. Okay, tell me one thing. When you guys have done paper 3 experiments, right? If you are A-level students, right? So when I have my hand here and I kind of, I release it. Tell me one thing. At this point, do I have velocity at all? I mean, do I have any kind of speed here? I mean, I'm literally releasing. Obviously, I mean, it's not a rocket that suddenly at time 0, you get this high speed or something like that. So if it was a rocket or something, if it had this, I don't know, a lot of fire, then it would literally at time 0, it would have a lot of speed, but it's not a rocket. It's a ball. I release it. So I can say that at time 0, my speed is 0. Exactly, it's literally 0. Now, okay, at this point, when I release it, it starts moving. So my speed slowly increases, right? My speed increases. And a fun fact, at mean position, velocity becomes the maximum. Velocity becomes the maximum. Okay, so let's increase the speed, and obviously I'm gonna tell you key how. I'm gonna prove it. Now, this is my maximum velocity. This is our maximum velocity. So this is V max. So I can say that this label is gonna be plus V max. Now, is it true that my pendulum has to eventually stop here, right? My pendulum stops here, right? Because it has to change direction. So the speed at this point is going to be 0. Now tell me one thing. If my speed is increasing, obviously it's gonna increase till a certain point. And from this point onwards, my speed is gonna decrease because it has to stop, right? It's gonna increase, and then suddenly it's gonna stop. That's not how physics works. That's not how physics works. That's not how this world works. When you want to have V is equal to 0, you got to start decelerating. So my speed is going to decrease. Now, this is speed 0 again, but when it changes direction, it's again going to start gaining speed. So it gains speed in the opposite direction, and it has a maximum speed at the mean position, and it then again decreases. So I get a beautiful sine graph, just like one of the students, just like US Man said, a sine graph. Okay, now let me tell you a little cool thing. This is how we made this graph using basic logic, but the actual method involves math. Let's try that. Okay, now what I'm gonna do is I'm quickly gonna decrease the signs, and I'm gonna make the displacement time graph again. No, it's not gonna be a negative sign graph. It's gonna be exactly what I made. Look at this. So this was displacement time graph, okay? So this was displacement time graph. Let's make it again. Oh, it starts from here. So I had a cos graph here. Now, this was x and t. Tell me one thing. What is the gradient of this graph? What is the gradient of this graph? Come on, guys. Let's see who's the smartest. Okay, it's not a competition, but what do you guys think? What is my gradient for the displacement time graph? What is gradient? Exactly. So gradient is, the y label divided by the x label. So x over t. Isn't that the velocity, right? So my gradient, the gradient here is velocity. Now, didn't I tell you that velocity at time 0 is 0? So doesn't it kind of remind you of something? V is 0 here. And according to this, my gradient is 0 here as well. Now, look at this. Look at this. My curve seems to be becoming, it's becoming more steep, right? So my gradient is increasing. How is it increasing? Well, make a line here, and now make a line here. Okay, so this color isn't good. Let me change the color. Okay, let's use red. Okay, let's go with, okay. So if I want to make a tangent here, and then I decide to make a tangent here, you guys can see that the gradient is increasing, right? It's increasing. Okay, man, I'll answer this. Just give me a while. Okay, but first, let me tell you one thing. Okay, first let's go with this. So my gradient is increasing, right? M goes up. My gradient is increasing. So my velocity, it's also increasing. Now there comes a point. So don't you guys think that at this point, right? At this point, velocity becomes the maximum because the gradient becomes the maximum. This is the point where your gradient is gonna be the max. So I can say that this point is the same as this point. So let's label these points as A and this as A as well. So this is A and this is A. And both of them have a beautiful contrast. Now you can see that the gradient starts decreasing. Why? Why? Because I know that at this point, gradient is 0 as well, right? Is 0. So my gradient is decreasing. So M goes down. M decreases. Okay, so now you can observe that at this point, look at this, guys. At this point, velocity is 0. So I can say that this is point B, and this is point B as well. So let's use it. Let's use an orange color. This is point B as well. Why? Because velocity is 0, and here my gradient is 0, right? Now the gradient seems to be increasing again. M goes up, and velocity is also increasing, and then velocity becomes maximum in the opposite direction again. Okay? Now, you can see that at this point, again, your gradient becomes 0. This also suggests that velocity is 0 at this point. So I know that's a lot of stuff to absorb, but that's another way to make this graph. Easier way, just remember that if you are starting from peak position, this is a crucial thing, at peak position, if you're starting at peak position, because if you start at mean position, stuff is gonna change. So I'm starting at peak position. And when I start at peak position, my velocity graph is a sine graph, and my displacement graph is cos graph. Okay, it's time for your questions. Yeah, oh, LOL. Time, okay, let me take the pictures of your questions, Abdullah, and the meeting is about to end, LOL. Okay, I took a picture. The meeting is ending. I'm gonna have to end this meeting. Let's continue this in the next meeting. I'm saving the screen. Okay, see you guys in the next meeting. Recording. Okay, so I'm gonna make the velocity graph again. This is the velocity graph. Okay. Now I know that the velocity graph is a sine graph. So let's make a sine graph like this. Okay. This is a sine graph. Now, I said that this is Vm, this is plus Vm, and this is going to be minus Vm. Now, it's a question for you guys. What do you think is going to be the equation? What is going to be the equation for this graph? Come on, let's see who can get an answer. Don't forget the formula that I told you in the last meeting. Come on, guys, let's see. What is the formula? Okay, so V sine theta, A cos. Bro, it's the sine graph. Bro, it's the sine graph. It's not the cos graph. Hey, look, guys, this is the sine graph, no problem. Okay. LOL. Okay, just a second. Just a second, I lost my screen. Okay, it's back. So I said that y-intercept is equal to the amplitude multiplied by the shape of the curve. Now, most of you have the right answer, but yeah, you have the right answer. So congrats, most of you. But obviously there were some incorrect answers as well. Shape of curve. Now, my amplitude is Vm, right? So I can say that, and y-intercept is velocity. Velocity is equal to, and mind it, this is not going to be V again. It's going to be Vm because this is my amplitude. And when you say V, bro, V is the y-intercept. So never do this mistake. This is Vm, sine theta. But just like the last time, this is my raw formula. This is not the refined version of the formula. Now, I know that theta, or the angle, I know that the angle is basically omega t. So, okay, no, Vm sine omega t. But there's one thing that we still have to do. That is this. V is equal to A omega sine omega t. Now, you're probably wondering, how in the world did we get A omega? Well, let me tell you. Yes. So let me tell you. When I had a turntable, I told you guys that V is R omega. Now tell me one thing. When my R is the maximum, maximum R, can I say that it's the amplitude? Because R is the distance, right? R is the distance. So just like we can call displacement, maximum displacement as amplitude, we can also call maximum radius as maximum, displacement. So max R, this is my R max. This is, okay. So this is R max, and I can also say that this is the amplitude, okay? So V is R omega, but Vm is A omega, because A is the maximum radius, and Vm, it's the maximum velocity. So let me erase this, and let me write it down here. So I know that V is R omega, and I also know that maximum radius is A. Is everyone clear about this? Because it's one of the most confusing things, you could say, for the ones who are beginning A levels. Okay. Okay, confirm one thing. Are you guys confused about A omega? Is this your confusion? Okay, so that's your confusion. Okay, no problem. Let me select this all. Let me decrease the size. Okay, tell me one thing. Velocity is R omega, right? this is the formula that I taught you in the last chapter, right? And you guys should also remember that one time I said something. So last time we were doing something. This is something different. So A is omega minus omega square x, right? So do you guys remember that one time I said, if I want to have the maximum acceleration, and I know that A and x are directly proportional, right? So if I want to get the maximum acceleration, I want to have the amplitude here. And what is the amplitude? That's the maximum displacement. Now tell me one thing. Displacement is in meters, right? This is a unit, right? Remember this, keep this at the back of your brains. Now tell me one thing. Isn't my omega constant? So can I say that velocity and the radius, they are proportional, okay? Now, what if I say that I want to get maximum velocity? Omega is gonna stay here. No, obviously I should have R max, right? The maximum radius. Now, what is the maximum radius? What is the maximum radius? Now, we also know that radius is also in meters, right? It's also distance. Henna, right? Radius is in meters. So can I say that this is also amplitude? Because both of them are distances. So it doesn't matter what distance you have. Displacement, radius, as long as it's a distance and it's a maximum distance, displacement. So you can say that this is the amplitude. So, let's erase this. And now you know that if you have any kind of question, let's say you have a paper, right? And they're asking you, okay, so candidate, tell us what is the maximum velocity. So instead of using the radius, you're just going to use the amplitude. There are some questions like that. So that's how. Now let me select and increase the size of it. That's how I got A omega instead of Vm. But the base formula, the raw formula, kacha formula. This is my, the raw formula, the uncooked version of the formula. But this is the final formula. And any kind of calculations, you have to use this formula. Okay, is this clear, everyone? And please note this down. Once you're done, tell me, and we are gonna derive something really cool. Yes, Ima, your conclusion is right. So yeah, you're right, Ima. Okay, great. Let's save it and let's clear. Now, so far, we have studied only one formula. So I have literally, in fact, we have three formulas. We have three formulas. We have A is equal to minus omega squared x. That's your basic formula, the formula for SHM. I also have x is equal to A cos omega t. And I also have velocity is equal to A omega sine omega t. Now we're going to be deriving the actual formula, something you're going to use in calculations. And this is, yes, this is one of the confusing things. So be attentive. Now tell me one thing. I know that not everyone here studies math, but there's this concept in math. If you have sine theta and you put a square, square, and then you add cos square, you get 1. This is a mathematical rule. For those who don't know, the bio students, unfortunately, you will have to remember it. So this is a rule, like literally, there's no logic. I mean, there might be logic behind it, but it's kind of advanced and we're not really supposed to do it right now. So just remember this. This is a rule. Now we're going to do something really cool. This is my rule. Let me move it up. Okay. Let me move it up a bit. That's really cool, Abdullah. You should definitely do it. Okay. Now, what I want to do is I want to apply this rule to these two equations because I have cos and I have sine. Now, let's make cos and sine common. So I can say that cos omega t is x over a, right? I have a cos omega t, so I just moved a to that side. And I can also say that sine omega t is what? We divided by a omega. By the way, this theta, you can literally replace it with omega t. So let me just do one thing really quick. Okay, so instead of this omega, we're gonna write omega t because we are dealing with omega t's and I don't want you guys to get confused. So this is omega t and this is omega t as well. Okay, what I'm gonna do is I'm gonna substitute these values, these numbers, these variables into this equation. So it's gonna be v divided by a omega squared plus x divided by a squared is equal to 1. Are you guys with me? Are you guys clear about this? Because in such calculations, there's a lot of times when the class is behind. Okay, that's amazing. Now, there's going to be some math here. It's going to be v squared divided by a square omega square plus x squared divided by a square is equal to 1. Now what I'm going to do is I'm going to move this to the other side. So we're going to get v squared divided by a square omega square is equal to 1 minus x squared divided by a square. So let me decrease the size so I can write. Okay. Now, I'm going to take something called LCM. I hope everyone is aware about this. I mean, as long as you were attentive in your 8th class, 9th class, etc. So it's going to be a square minus x square divided by a square. So yeah, that's basic LCM. So if you don't know, man, I guess if you don't know, I can still tell you. So yeah, back to childhood. Okay, now I know something here. I know that a square is in both of the sides. Yeah, you can. Okay, so a square is, in these both sides, so I can cut them, right? Now, I'm going to keep v square as my common. In fact, let's use the black color again. Okay, so v square is coming here. Velocity is here. Now, my acceleration, omega square and all the other stuff are coming here. So a square minus x square. Now, what I'm going to do is, I'm going to take an under root for this whole side, and I'm going to get something cool. And this is going to be my final equation. So the final equation I get from this is going to be velocity is equal to omega under root a square minus x square. Now, there's another thing. In math, whenever we take an under root, we have to do something here. Now, let me show you what. So when I do an under root, I'm going to place plus minus. So there's going to be a plus minus here as well, because that's just a math rule. So plus minus here as well. So plus minus, whenever you do under roots, you always get plus minuses. So it's a rule. So velocity is equal to plus minus omega under root a square minus x square. Okay, are you guys with me? Does everyone understand how to derive this? Okay, Basil, you just raised your hand. Do you have a question? Okay, so I assume that was a mistake unless you send me a question now. Now, let's put some labels. Now, this is my velocity. This is velocity. This is no problem. This is angular frequency, not angular velocity. This is angular frequency because we're studying SHM. This is amplitude, and this is displacement. Now we don't have space here. Velocity of what? Velocity of what? Of course, of our pendulum. What else? You're gonna see later. We're gonna do We're gonna do questions later on, and you're gonna understand exactly. But since we're studying simple harmonic motion, so it's obviously velocity of the pendulum. Come on, like let me show you. I'm gonna show you on the next page. Yeah, of the bob, literally. Yeah, of the pendulum, of that thing that spins. It has velocity as well. Because come on, we have acceleration, right? So how in the world can you have acceleration when you don't have velocity? Because what is acceleration, right? Okay, now this equation right here, this equation is equation for every simple harmonic motion. So equation for every SHM, like literally is the equation for all kinds of SHM. So whenever you have velocity, omega, amplitude, and displacement, you can use these terms and you can find out your answer here. Yeah, by the way, this derivation, it comes in the paper. Exactly, Cambridge Assessment International Exams, P4, paper 4. So make sure after today's class, you try to practice this on your own, like literally put aside everything, put aside your notes, take a paper, take a pen, and try to reimagine this scene and try to derive this equation. Do these challenges frequently because that's the only way you can understand physics. And if you're skimming through your notes, especially these equations, you can never learn physics because this type of physics, it comes with practice. Like literally in 3 months, even I might forget it if I don't practice. Okay, so has everyone noted it down? Okay, that's great. So I'm clearing the screen. Now we're gonna move on to the next little thing. Okay, so let me show, I might as well. So this is a pendulum. This is the normal line. And okay, so this is our pendulum. Okay, so this is my velocity. And at this point, when you are releasing, my velocity is obviously gonna be 0, right? So it's the velocity of this bob, right? So velocity is 0 at this point. Okay, so this part is more of a recap of what we did back then. It's literally 2 graphs again, but I'm not gonna make them again. But I wanna show you guys something cool. We are gonna prove with the formula above something. Okay, so our formula was V is equal to plus minus omega a squared minus x squared. Now let's look at peak position. Okay, so this is my peak position, like P and M. So let's look at peak position. Peak position. Okay, now I know that at peak position, my displacement is maximum, right? X is equal to A, right? So I can say very confidently that my X is A. Now, when I substitute this, check this out now. So check this out. So A squared. Now I know that there's X right here, right? So when I substitute A, so US man, yeah, it's in our syllabus. It's in our syllabus. You are supposed to know it. I know it sounds kind of complicated, but yes, it is in our syllabus. Okay. Now check this out. I know that A squared minus A squared is 0, right? So that's how my velocity is 0. So we literally just proved with this formula that at peak position, your velocity is 0. So by using this formula, we can prove different things. And this proves that this formula is for SHM. Now, what if I suddenly decide to say that I want to know for mean position? Mean position. So Note another thing, this formula is to find the velocity. Now you're probably wondering, okay, so why didn't I put v is equal to 0 at the start, and why didn't I find a? Because come on, velocity is here, right? So in most of the cases, this formula is going to be used to find velocity. Now, I know that, okay, what is my displacement at mean position? Come on, guys. What is my displacement at mean position? Yes, it's 0. So if my displacement is 0, then when I substitute it into this, it's going to be a square minus 0. So velocity turns out to be, okay, it's plus minus. I forgot to add plus minus. Yeah, plus minus. So velocity is going to turn out, it's going to be plus minus omega under root a squared. So, these get canceled out. Let's use a red to show that. So they get canceled out, and I finally get v is equal to plus minus omega a. Now, look at this. Didn't I tell you before that if I want to find velocity at mean position? Okay, check this out. Didn't I say that velocity, maximum velocity, V max, is omega a, right? So we know that V max is omega a, right? Now, one of you students asked me, how do I know that my velocity is maximum at mean position? So if you are listening to this now, man, check this out. It doesn't say V max, it says velocity. And I am at mean position right now. But what am I getting? Omega a. So isn't it a proof? Isn't it proving the fact that at mean position, my velocity is maximum and my displacement is 0. And I also know that at peak position, velocity is 0 and x is max. So this is why we use this formula, because we can do cool stuff like this and obviously all the calculations and stuff. Okay, is everyone clear about this? I know, right? So okay. Yeah, bro, it is necessary, because if I write minus, okay, let me tell you one cool thing. Why do you think I have plus minus here? What does it show? Come on, it's a question for you guys. What do you think this plus minus means? No. What do you think this plus minus means? This plus minus omega a. What do you think? Exactly, direction, right? So if I use a black color, I can tell you that this means that it's in both directions. So in the last class, some of you even asked me, how can I say that the negative thing is not the minimum and is the maximum? Because bro, omega a is the maximum velocity, right? So plus means it's the maximum in the upper part, right? And minus means it's maximum in the lower part. So now you know that if I say that something is minimum, bro, it's not here, it's here. This is your minimum. This is max, and this is max. So it applies for all kinds of vectors and stuff. Okay, so I hope this is clear. And I'm glad this is fun as well. Okay, so note this down. And I'm gonna assign you a small task. Now what you're gonna do is, I hope everyone has Discord. I am gonna ask you to make a graph, and make sure you don't copy, try to do it on your own. And I'm gonna tell you the correct graph tomorrow. And come on, I know everyone has books, everyone has Google. Just try to do it on your own. Okay, so can I remove this? Can I erase this? Bro, you can't go home yet, man. Hey, wait, wasn't today lockdown? I think the whole city was supposed to close today. I don't know. So how can you go home, man? The roads are blocked. Okay. So you guys have noted, I'm gonna remove this. Yeah, you guys can fly, LOL. Okay, now this is a homework for you guys. I am gonna make a graph. I'm not gonna make a graph. Yeah, I know, right? I know, right? I know that homeworks are not so fun, but let's do this in a fun way. So this is velocity and this is displacement. So this is your homework. Let's see who can do the right answer. And come on, don't answer here because I know some of you might know the correct answer. So this is your homework. Take a screenshot and send in the Discord group so I can see, no problem. So I can see who understood this chapter. Trust me, this is easy. You can literally use the equations. You can literally use the actual pendulum motion and you can solve it. And trust me, these graphs, every single detail, it's going to come in the paper. And the topical for oscillations is huge. So start solving ASAP. Because I don't think we're going to be able to finish, I don't think we can finish SHM in this week. It's going to take the whole next week. Okay, so I hope everyone is fine, everyone is clear. See you tomorrow. Allah Hafiz. Bye-bye. Okay, see you guys, inshallah, tomorrow. End meeting for all.